Okay, guys, so take your notebooks out and write today's date, which is Wednesday, September 21st, and you're going to put 213. And specifically, we're talking about more angles formed by transversals. Okay, so we have previously learned about corresponding angles, and hopefully that was yesterday on Tuesday when you guys watched 212. And what you guys should have learned about corresponding angles is when lines are parallel, and only when lines are parallel. Then when you draw a transversal, keep in mind the transversal is the line that intersects the two parallel lines. So let me put my parallel marks on so you know they're parallel. Corresponding angles, which are angles that are in the same location but a different intersection. So these angles right here are equal to each other. So corresponding angles are congruent when the lines are parallel. Okay, that was our main objective from yesterday. Again, when you have two lines that are not parallel, you can see very clearly that this blue angle right here is not the same as that blue angle. I can't slide it down the transversal. Can't take this angle and slide it down, and it's not going to fit on top of there. And that's because although these are called corresponding angles, these ones are not equal because the lines are not parallel. Okay, so they're still called corresponding, they're just not equal because they're not parallel. These corresponding angles here are equal because the lines are parallel. And I keep saying this other word. We're finally going to, in your notes, define this word congruent. Okay, congruent means that if you can take a geometric figure and slide it, rotate it, or reflect it so that it lands on top of the other one, that means that they're the same size and shape, and we call that being congruent. Another word for congruent is to geometry as equal is to algebra. So you guys are going to be seeing me write this sign, and this sign just means congruent. Okay, it means equal. And so we've been dealing with these triangles below that you guys see in 224. And so they want you to list the congruent pieces of this triangle. So I'm going to zoom in a little bit. Because this is an isosceles triangle, so this should be in your notes, you should know that those two sides, and we call those sides AB, would be congruent to CB. So that segment AB would be congruent to that segment CB. We also know that because if you fold it, you have angle A, which is congruent to angle C. Okay, so you have those parts by reflectional symmetry. You know that those parts are equal in that triangle. On 225, we're going to be looking at some other types of angles and their relationships. Okay, so it says use what you know about vertical and corresponding and supplementary angles to find the measure of angle B. Okay, so we're pretending that angle A is 48 degrees. So we're going to say this pink angle right here is 48 degrees. And if that pink angle is 48, because I see the parallel lines, I can slide it down my transversal, and that means that this pink angle is 48. Okay, so again, if angle A is 48, because it's on these parallel lines, you can slide it down, and this pink angle is 48. Now, because of vertical angles, I also know that B has to be 48 degrees. Okay, so we know that that's clearly 48 degrees. So it says, when I translate one of the angles along the transversal, I notice that its image of the other is vertical. That way I know A and B must be congruent or equal. Okay, use her method and tracing paper to figure out if these are congruent or supplementary. So she wants us to see, and again, we're dealing with parallel lines here. So if I was to take angle A and slide it down, would A and B be equal to each other or supplementary? And so you can very clearly see that A and B are supplementary. A and B are supplementary. They add up to 180 degrees. Sorry, my kids are getting home from football. So angle A B add up to 180 degrees. Okay. Over here, let's see if A and B are equal or if they are supplementary. So I'm going to take A right here, and again, I see the parallel lines, so don't worry. And I'm going to take A and slide it down. Okay, so I know A fits in right there. And I can see that A and B are vertical, and because A is vertical with B, that means that A has to be equal to B. Okay, A is equal to B. So look at the difference between these. You can very clearly see those vertical angles. Okay, whereas over here you see that they're not. They're supplementary. Then we have this one, and I have my angle A. Again, I have my parallel lines. I always check for that parallel line. I can take this angle A and I can slide it down my transversal because of the parallel lines. So angle A is the same as this angle A down here. And because angle A and B are next to each other, I would say A is supplemental to angle B. That means that A and B together add up to 180 degrees. You can see the windshield wipers swinging back and forth for A and B. So A and B are supplementary. So moving on to the next one, we're going to define a pair of angles that you guys are going to see a lot, and these angles are called alternate interior angles. They're called alternate because they're actually on opposite sides of the transversal. So here's my transversal. So you can very clearly see that one's on the left side and one's on the right side. And they're called interior because they're on the inside of the parallel lines. So if I'm to actually kind of smush these parallel lines together, you can see that they're on the inside of this. Okay, so we call those alternate interior angles. I had a crazy geometry teacher, and she called them Zorro angles because if you make a Z, those are your angles right here, okay, inside of your Z. So then it says to find another pair of alternate interior angles. And so again, you're looking on the inside of the parallel lines, and except this time I'm going to go on the right side and the left side of the transversal. And you can see you're kind of backwards, the Z and the backwards Z that you got going on. So these would be another pair of alternate interior angles. And I would call those angles DCF, and is alternate interior with angle EFC. Okay? Think about the relationship. So if lines are parallel, what do we know about these angles? And I'm just going to work with the pink ones for you guys really quick. So what do we know about these alternate interior angles? Because these lines are parallel, right, I can technically take this angle right here and slide it down my transversal. And those would have to be equal because we know corresponding angles are equal. And then because these are vertical, those have to be equal. So this is almost like a shortcut. Instead of sliding it down and then looking at the vertical angles, you can jump straight to, hey, these are alternate interior angles. So again, going back here, in your notes, I want you to put this right here. If lines are parallel, then alternate interior angles are, and I want you guys to put equal. Then I want you guys to draw this diagram up here. So in your notes, again, you guys are going to take your notes and you guys are going to draw your parallel lines. Make sure you label them as parallel. You're going to draw your transversal and you're going to highlight your alternate interior angles. So you have a picture in your notes. So if lines are parallel, alternate interior angles are equal. Okay? You can also use this arrow diagram if you'd like to. It's just showing you that it means if the lines are parallel, then the alternate interior angles are congruent to each other. Okay? And then the next set of angles that we're going to be talking about is something called same side interior. And again, they're called same side interior. Interior because again, they're on the inside of the parallel lines, except this time now they're on the same side. They're both on the right side of the transversal. So those are called same side interior. So let's see what we can find out about these angles right here. So if I take this orange angle, and I know corresponding angles are equal when the lines are parallel. So if I take it and I slide it down, you can see that these angles don't fit on top of each other, but you can very easily see that together these two angles make 180 degrees. So same side interior angles are supplementary. Okay, in other words, they add up to 180 degrees. So again, if you want to use corresponding and slide them down, you can, but know that if this is 100 degrees, then obviously this same side interior angle here would have to be 80 degrees. And that's again because if you take this 100 and slide it down, it fits right here, and those two have to be supplemental to each other. Okay, so again, in your notes, you're going to draw a picture that looks like this, right here actually, and you're going to put same side interior angles are supplementary. So they add up to 180 degrees. Okay, and then we're going to skip 28 and 29, and we're going to go right to this. Okay, 2-30. In your notes, I want to make sure you have this. So vertical angles are always equal. And vertical angles are created when two lines intersect. Okay, you only have two lines. And then in your notes, I'd like you guys to go ahead and draw a picture. And this is probably the most important part. And again, if you want to put angle measures, like for example, 50 degrees, 50 degrees. Okay, vertical angles are always equal. The next one, corresponding angles are equal when lines are parallel. So in your notes, make sure you have that and make sure you draw your parallel lines and your transversal, okay, and that you have your corresponding angles labeled right here. Okay, and again, those are equal. So for example, if this is 60 degrees, this is 60 degrees, when the lines are parallel. So in your notes, I would also kind of circle that parallel mark. The next one is called same side interior angles. And again, they are supplementary when lines are parallel. Okay, and again, let's go ahead and draw our, it's thundering here. We'll go ahead and draw our lines. Okay, and this angle, this orange angle right here, and this green angle right here, they are going to add up to 180 degrees. So for example, if this orange angle is 100 degrees, the green angle has to be 80 degrees. Okay. And again, those are on the same side. Oh, I forgot to do my parallel marks. Only when the lines are parallel, okay? Same side interior angles are supplementary only when the lines are parallel. Straight angles are two angles together that make a straight line. I call them my windshield wiper angles because I picture this like connected here and this windshield wiper going back and forth. And so you can see very clearly that this goes back and forth and back and forth. And so those two angles are supplementary. They add to 180 degrees. And then your last pair of alternate interior angles, they are equal when lines are parallel. Okay, and again, I would draw that picture. Bam. There we go. Okay, I have my alternate interior angles that are equal. And again, those are only equal if you see these parallel marks right here. So again, if this is 70 degrees, this has to be 70 degrees. And again, I call those my Z angles, my Zorro Z angles. So you can draw little Z's, okay, like that. And then you can draw the Z's going the other way as well. Those are your alternate interior angles, okay? And this is the main idea of 212 and 213. please make sure all of this is in your paper notes so that you can use this on your tests and your quizzes.